What an awesome show I've got for you today. We just wrapped up. It was another marathon session, as they always are. But for anyone who questions why we do marathon sessions, it's that almost everybody who comes on here is an expert in their field. They have a lifetime of experience, or very close to it. And I can't ever ask somebody who has that much experience to come on and cram it in an hour or less. There are some shows that do a fabulous job of that. It's just that this show, I like to give them free reign to talk about anything they want, go into depth as much as they want, or at least as much as they think the listener is able to process. And today's episode is no exception. My guest is Dr. Paul Wood, who is currently the Vice President of Engineering at Ping Golf. And we go pretty deep into anything and everything that has to do with golf clubs. For example, the design of the club, how they come up with innovative ways to improve them, and not just improve them by a little bit, but improve them by enough of a margin that it's noticeable to the design team and the golfer themselves. What types of materials do they use? How do they go through their fitting process for drivers, for irons, for wedges and putters? Dr. Wood has been instrumental in all of that in his 16 years at Ping. This is just a fabulous show, at least for me, who's someone who's spent a number of years doing club fitting. And you're going to really learn a ton about everything that has to do with clubs. We get into shafts and load patterns and how Ping has developed and Dr. Wood has developed their systems for design and for fitting, and as he collaborates with a number of other people within the company. We talk about Ping, the company itself, how the Solheim family established that they are going to make things that allow golfers to improve, and they will not settle for anything different, and how that culture and that mantra has stayed with the company, and everyone that comes on board just loves adhering to that and doing everything they can to improve the products that they come out with and they make. The two sides of products and the innovative process, how you balance the scientific and or the engineering aspect of a club design with the playability design and the feel that the golfer is going to have, and then how all those things interrelate. So a whole bunch of phenomenal things in today's show. Dr. Paul Wood is not so much behind the scenes as he's very well known within the golf industry, but those of you who are not club geeks or in the coaching world and have heard him lecture, I think you're going to find him very informative, very interesting, and it's going to come out and across how smart he is and the wonderful things that he and Ping are doing for you and the golfing world. So, as always, please give a big, warm Golf 360 welcome to my guest today, Vice President of Engineering for Ping Golf, Dr. Paul Wood. What's up, everybody, and welcome to the Golf 360 podcast. I'm the host, Pete Popovich. So you may be asking yourself, what is Golf 360? And Golf 360 is a show that was designed to introduce you to people associated with the game of golf to help you improve not only at your game, but also your life. Almost all of our guests are from within the industry in some way, shape, or form, but some of the guests we have are from outside the industry, and it mainly revolves around the business world with a few others scattered in here and there. Now, all of the guests that we have a few things in common. One, they all were highly successful and accomplished in their field. Two, each has something to pass along that will help you in your game and your life. And three, they were all more than willing to give back by passing along the things that they use to help them in their career, and even some of the mistakes that they made so that others don't make them in their journey. So I hope you find listening to them as enjoyable as I did interviewing them, and that each and every one of you benefits from the information that they so willingly and graciously pass along. Hey, everybody. I want to give a big shout out to a new sponsor of the Golf 360 podcast, and that's Affinity Wealth Management Group. We all work exceptionally hard for our money, and none of us can afford to let that fall into the dark abyss of the big box financial service firms and their jack of all trades and master of none mantra, which basically means you become a number within a cookie cutter model that's also often accompanied by massive fees. Your future deserves more than average returns and little attention. At Affinity Wealth Management, they ensure that your financial goals receive highly individualized, tailored attention from experts, not just advisors, who are in the industry to be great and not average. As a client of Affinity Wealth, you receive a customized solution to your customized life, keeping in mind your family's financial situation, values, and risk tolerance. Call Affinity Wealth today for a no-cost consultation with one of their experts at 724-754-8200. Again, that's 724-754-8200. Or you can also check them out on the web at www.affinitywealthmg.com. That's AFFINITYWEALTHMG.com. This podcast is brought to you in part by Just Thrive Probiotic. You may be surprised to learn that your digestive system is the key to creating and maintaining the quality of your physical, mental, and emotional health, and it's one of the body's most essential systems. That's why the majority of nutritionists today highly recommend probiotics as an indispensable nutritional supplement. As a discriminating consumer, you've probably been searching for a probiotic that is proven, potent, and effective, and you found it. Just Thrive is your best choice for maintaining a healthy lifestyle. Just Thrive Probiotic captures the power of hundreds of thousands of years of nature's design with a specialized bacillus strain formulation that guarantees survivability through the stomach and upper digestive system. Supports optimum gut health, digestive health, immune health, and delivers antioxidants. Great for adults, kids, and the whole family. Use promo code GOLF360 at www.thriveprobiotic.com for 10% off your order. Okay, everybody, we got another amazing guest on today. He's also one of the smartest people in golf. He's doing fabulous things with club design and everything to make everybody's game better, from beginners all the way up to tour pros. So I'd like to introduce everybody to VP of Engineering at Ping Golf, Dr. Paul Wood. Doctor, thanks for coming on.
My pleasure, and hello, everyone.
I say this all the time that I've been very fortunate with this podcast because this week is the second anniversary for the show, and to get someone like you on, and as we talked about before we came on, that somehow, some way you don't have anything really scheduled this afternoon that allowed this to happen is my benefit and everybody who's out there listening. So I guess karma and timing are somewhat of everything, or most things in life.
Yeah, that is, and for the record, that's a very rare thing. In fact, some of my afternoons recently have been building golf clubs. I've sent out a couple of things on social media about it, but we're so busy that it's all hands on deck. So if you bought a pin club in the last couple of months, there's at least a small chance that I ended up helping build it. So apologies for that. It's not my strongest suit, but needs must. Actually, it's been a great experience to have everybody really understanding what goes into building clubs, because our team that do that are amazing, and it's easy to forget. You think it's just gluing a shaft on, throwing a head and a grip and a shaft together, but we've had everyone down there, including our company president and our CEO John, who he was building clubs before I was alive, so it's kind of fun to see him building clubs.
And you've been at Ping for quite a while, almost 2 decades, and you've had many titles. And I'll just say a couple here. It pulled them up as it was doing just a little bit background research on you. I mean, from research engineer to engineer to research engineer manager, director of innovation, up to your current position of VP of engineering. And which of the positions have you enjoyed the most?
That's a good question. It's hard to beat. I think it's hard to beat the position you start in. When I first came to painting, and I had no idea what to expect, and I was, this kid who'd studied mathematics in Scotland and thought it'd be fun to try and be in the sports industry, and sort of somewhat speculatively asked a few golf companies, hey, are you hiring mathematicians? To coming out here and realizing there's a ton of cool stuff still to be discovered in golf. There's a lot of, that's what I thought, there's a lot of very complex physics and difficult mathematics and things that require a lot of research. And it was great fun just coming out here and getting stuck in and discovering things for the first time. And, and then finding out that Karsten Solheim figured that out 40 years ago. Okay, great.
Yeah, so physics doesn't change over time, does it? It is what it is.
It doesn't, but what has changed is our ability to measure stuff. Like, that's the really big thing. The tools I have and my team have, and they've changed in the time I've been at Ping, but compared to what Carsten had access to and what he was able to discover, before you could do simulations on computers and before we had radars tracking every ball, it was pretty remarkable. I came along just at the right time where we did, we got our first TrackMan unit just before I started. We had one, the company had one TrackMan. And for a while, we were the first golf club company to have a TrackMan. And now we own, I don't even know how many, a couple of hundred of them.
Wow.
And, just in the 15 years I've been at Ping, that's really exploded. We have our own bespoke motion capture system, which we wouldn't have dreamt of 30 years ago. We have access to, fluid dynamics simulation tools that didn't exist, 15, 20 years ago. So it was fun. I mean, it's hard to beat, that first couple of years in a completely new job. And I love that. But I love what I'm doing now. I get to kind of see everything that's going on. I don't do much of my own research, but I live vicariously through my whole team and get to see all the things we're doing. So that's a lot of fun too.
Mm-hmm. And is it? I've heard numerous times, and you could be one to verify that the golf side of Ping is just a small portion of the company. That they're more, is it aerospace or in engineering for NASA or some bigger entity?
Back in the day, there was. I mean, casting manufacturing made all sorts of things, but no, we're very much a golf company, and it's 99% of what we do is golf clubs and golf bags.
So is it all that technology was able to be shifted over from the engineering company into the golf company, which was it's had to have given you all a leg up.
Yeah, what's interesting is we're actually, my understanding, and this is before my time, we were a golf company that leveraged some of the knowledge we had to do other things rather than vice versa. So it was the things that we understood from having made golf clubs that allowed us to make things like, I know they did make some aerospace components and all sorts of things. So we've always been a golf club company first and then used that to do some other things.
Very cool. Specialize. You all have gone the specialized route, all in on the golf, which is done wonders for. I mean, you guys have had some phenomenal equipment come out over the years, and I hope we'll get into that a little later. As far as your positions, you're more over a team where before you were kind of able to. Play with all the toys, so to speak, and just experiment and see.
I mean, I'm pretty
ideas.
lucky. I still get to play with some of the toys, but I don't have time to kind of lead many research projects these days. It's a little bit here and there. Our team as a whole we oversee everything from the initial innovations, so kind of technology development, looking at new materials, new manufacturing methods, things like that, through our testing group, our design team, the people who are responsible for actually making this is the G425 driver or the G710 iron or whatever, through to commercializing those products, and then actually the manufacturing engineering team that supports how do we build it. So that's, it's a wide view. We also have our machine shop in there. That's part of engineering. So anything to do with how we research, design, test, and build golf clubs is part of our remit.
Mm-hmm.
It's pretty fun.
What would some of that entail? Just if you could just shed some light without giving away company secrets.
Yeah, I mean, that's, I could probably talk for an hour on some of that stuff. I think in general, the aim, we view ourselves as being it's a knowledge development endeavor, right? We make products, every, whatever it is, 18 months, 2 years, we come out with a new driver or a new iron or whatever. But the goal is to keep learning and knowing more in relevant areas, knowing more about the best materials we can use, the best manufacturing methods, aerodynamics, how to move mass around to improve forgiveness, knowledge of the customer themselves and what they're looking for, and some of the fundamentals of sound and feel, and anything that goes into making golf clubs. If we can keep learning and building on our knowledge environment. And when it comes to design a club, you're kind of picking from the tree of this is all that we know. Let's now design the best club we can. And then we'll trust that 18 months later, when we come to do it again, we've learned enough more that we can make a better golf club. And so in some ways, it's kind of simple. We keep trying to build on the knowledge. We keep trying to understand how to improve performance in one way or another. And as long as we keep working on that and trust the process, then you bring these, we call them incremental gains. You try to, every now and again, some major technology comes along that revolutionizes the industry, but more often it's a series of small things that add up, incremental gains in moments of inertia of a golf club, of center of mass placement, of some technology that affects sound and feel, of aerodynamics, and you add up all these little things, and that's what actually adds up to the best performance. It's not one thing. So
how do you make the determination? So you mentioned four things, right? How do you, as a team, and then you as the overseer of the team, determine which of those you're going to utilize and basically what the recipe is? Because you're sitting there trying to design something as an engineer that's going to perform the best. But if the general public doesn't grasp that concept, or they don't like the sound, or the way it feels at impact, or a lot of different variables, then the best club in the world sometimes doesn't seem to have the numbers, and then you're getting calls from accounting, and next thing you know, you got to change a design that's phenomenal to meet maybe a not so educated view of what's going to work for a person. So I guess
yeah,
my question is, how do you
no,
navigate around those things?
it's a great question. And that's the art of being a club designer, is managing those trade-offs, right?
Mm-hmm.
That we try to flesh out what are the trade-offs, and then the designer's job is to say, okay, given everything that we know, I could make the aerodynamics better, but now the club's going to look funky, or now the center of mass is not in a place that's quite as advantageous. So you're managing all these trade-offs of different variables, and their job is to say, right, this combination of factors right now gives me the best performance. And then the innovation team's job is to try to break trade-offs and say, okay, how do I give you better aerodynamics without sacrificing center of mass location? How do I give you, better spin rate without sacrificing cosmetics? Whatever that is.
Mm-hmm.
That's innovation, is when you break a trade-off and say to the designer, you can have both. You can have your cake and eat it at the same time.
Yeah, it's not an either or question. It's an and
Right.
question, right?
That's kind of the definition of innovation. It's easy to say we can make a driver super aerodynamic if you don't care about anything else. You just make it shaped like a bullet, right? But now, now try finding the center of the face when it's designed like a bullet. It's not going to work as well. So kind of one variable design is easy, but it doesn't get you very far. Where we're kind of lucky, I think, is that the company is performance first, and it always has been. And as far as I'm aware, it probably always will be. That, John Solheim and John K. Solheim come from an engineering background. They're very philosophically true to, to what Carsten started at Ping, and was it, how do we help you play your best? And then we'll figure out how to explain to you or tell the story or build the other parts of the club around that. And sometimes we do a better job than others of telling the story, or like you said, it's hard to educate people. You don't want people to have a degree in engineering just to get our golf clubs, right? But so that's what, it's my job and my team's job to try to translate. You don't care about the engineering, you care about how it performs. I care about the engineering because it's fun. But if you're an engineer, but you care about, did I just outdrive my buddies, or did I just manage to knock it right next to the pin and get it to stop, or did I sink the putt? And so we have to translate the more abstract world of engineering into, does this help you get the ball in the hole quicker?
Yeah,
and does it have the look, sound, feel, all those things that
it
we think are
seems
important?
it seems to be a thing that you the greatest products, if you look through history or modern history, and I'll use Apple as an example because they're so easily understood, in that it obviously had, when it came out, and now the competition is ridiculous. But when it came out, it was so different and offered so many different things, especially from the artistic and creative side that nobody else was having. But that was, I would say, was the engineering aspect, right? The technically and behind what anyone could see, it was doing groundbreaking things. But then they took what I would consider, or I think most would consider, the creative side and the aesthetics of it, and made it as sleek and cool and hip and everything as possible. And I would have to think that that same type of concept would go into the design of the club, which is what you're doing for, practically speaking, behind the scenes, right? The research and the development. And then how do you work with the aesthetics of the club? As we said, you've got to sell a product that's going to make somebody better, but they have to believe it and they have to, appreciate it. And usually looking at something and liking it is one of the first steps to get them to do that.
Yeah, it's tricky. That's where it's a real team game, right? The engineering team is made up of subject experts in some of these very deep topics, like really understanding metallurgy or composites, or my case, it was mathematics. We have aerospace engineers. Then we have folks who are experts in mechanical engineering and CAD in the design of the club. And then with that project, there'll be an industrial design expert too, and their job is to advocate for the industrial design side, which is exactly what you said, is merging how the club looks, sounds, feels with the mechanics of the club to end up with something that satisfies both sides. Because like you said, if someone doesn't try it, they're not going to buy it, right? So it has to be something someone wants to actually try.
Mm-hmm.
And there's different ways to do that. I mean, part of it, word of mouth. If I play golf with you and normally I outdrive you and your new driver is helping you hit it 10 yards by me, I'm trying that club, whatever it looks like. But often it's closer than that. Often it's a bit more, okay, you can't demonstrate something quite that extreme. So it needs to be something you actually want to try out and you can visualize. Yeah, I could see myself playing that.
Mm-hmm. And are you, as far as the people who are involved in it, are you over everybody for club design in that way, or are you over one portion of it?
Yeah, I kind of oversee, so I'm sort of I guess, hopefully the glue that knits it all together. So we have a director who oversees product development side. That's Ryan Stokey. We have a director who oversees innovation and testing. That's Dr. Eric Henderson, who you've met.
Mm-hmm.
We have functional managers for each of these areas, and we set things up to be teams. Working on it. It's not one guy who oversees the next driver. It's a team of people who are responsible for different aspects of it, and kind of force them to work together and advocate for the different sides of it. And it's not like we are still a company. It's not like it's not like we ignore things like the accounting side and the costing and the supply chain. It's a nice position to be in, knowing that we're performance first. It starts with this club needs to help someone play better golf, and then let's do everything we can to make sure that it can be commercially successful within that.
Yeah, it sets the goal of the company is right there for everybody to know and understand going in. Like I'm sure when you started, you were introduced to that probably fairly quickly, and it said, "Hey, Paul, here's what we do. We make these great golf clubs for people. They have to function first, and then we can deal with all the other things later." So and all the great companies have that. They know who they are and what they represent and what they stand for, and then they go ahead and create things that fall along those lines.
And a big part of my job now, in my role, kind of overseeing things in engineering, is precisely working with our sales and marketing team, working with our supply chain team and our accounting and the cross-functional groups. When I started and I was building golf ball flight models in our R&D team, I was kind of removed from that side. It was, hey, you concentrate on doing the physics stuff and go for it. But now I kind of get a view of the whole company, and there was something really nice about that, of seeing how the whole company works.
Mm-hmm. What was it? Somewhat eye-opening when you first started there. I remember, so I grew up just north of Detroit, and General Motors had an institute as a university, and I had some friends that went there that became engineers, and after we all graduated college, we get together and play golf or catch up and have beer, dinner, whatever. And a couple of them told me that a couple of their first meetings, now they're graduates. They everybody thinks they know everything there is to know about whatever field they're in, and they go into some of these meetings and they're thinking that they're going to knock all these old timers over with their knowledge, and they present it, and then they just get torn to pieces. Right? These guys, what about
Fortunately,
this
no
and what
one.
about this? And they're like, I had no idea what they were talking about.
Yeah,
Like a reality check,
fortunately,
right?
no one tore me to pieces when I arrived at Ping, which was nice. But was it eye opening. I moved from I was in a academic research group at a university in Scotland, and I moved over to Phoenix, Arizona, and it was a whole different world. And as you know, Ping has a lot of people that have been here a long time. And here's me, I've been here for 6 weeks, and I have a silly accent, and I've just arrived from Scotland. And there's a bunch of guys who, been here for 30, 40 years and go way back with Carsten. And obviously I wasn't lucky enough to meet Carsten. He passed a few years before I started. But, I remember interviewing with John Solheim and like, wow, you started this company in 1959. Okay. I was born in 1979, So I got a very firm grasp that, yeah, the things that he has seen and not, and done in golf already kind of probably surpass anything I will find out in my career. I mean, he'd been doing it for 45 years when I started. He's over 60 years now. And it's sometimes just sitting down with John and picking his brain is incredibly valuable because his depth of knowledge on a whole bunch of topics is just amazing.
Yeah.
So it's fun, but there's a family feel about it. So everyone is they were pretty gentle with me when I started and very welcoming. And we try to be the same with new people now. And, bringing in different perspectives and people who see things a different way is a good thing. But it's great to have some folks that really know the ins and outs of the company. I mean, we've named some of our more recent putters after some of our long time staff. And it's been really fun for all my team a lot of us, haven't been at Ping that long to learn about some of these early employees. I was just talking to a historian. One of our new putters is called the CA70, right? And CA stands for Chuck Adelsberger, and 1970 is the year he started at Ping. And so kind of for us, learning the stories behind some of these names has been really fun. Harwood, our Harwood putter in the new line was named after Mr. Harwood, who the joke was that he was the machinist that came free with the building when we bought a new building. It was genuinely he genuinely did come with the building and was one of the first machinists at Ping. And so it's just fun to kind of hear and connect with the early days of the company.
Some of the old timers I knew within this industry and have met through my career, and I heard this story more than once. You might know it, and I might be wrong, but it dealt with the very first, I believe, the putter that Karsten had made, and I don't know if it was the first one he made that was the ping that was like the rectangle and actually made the ping noise, or if it was the first plumber's neck model. I can't remember exactly, but he had taken it. To one of the tour events, and I want to say it was in Ohio somewhere, and he had passed out a couple, and this was obviously back in the '60s, so you've got Arnold Palmer and Jack Nicklaus, and that whole era, and he had given them to somebody, and they went and hit a few on the putting green, and everyone saying, "Wow, this is really nice," and all these other things, and there was a particular golfer, and I don't want to say their name, but they were very, very highly ranked, and said, "Well, I think if it might feel better if you had some weight over here and did this maybe and shorten this." And Mr. Solheim snatched the putter out of his hands and said, if it was supposed to be there, I would have put it there already. and the golfer's like, well, that's not kind of what I meant. And Mr. Solheim just kind of turned and walked away, and he didn't want to hear it.
That sounds about right from what I've heard some great stories, and I'm certainly not the not the true authority on this stuff, but there's some great stories of the very early days. And I actually bumped into what we think was the first putter that we ever submitted to the USGA. And I was there, I was visiting the USGA, and they just had it kind of like out there in the testing lab. I think it was a mistake. Maybe an intern had got it out. And I'm looking at this putter, and it's It's got a little dent in it, and I look on the bottom, and it's it's a Redwood City putter. So before we moved, the company moved to Arizona, I knew they were fairly rare. And I talked to our historian, and I took some pictures, and he said, yeah, that's one of the early brass putters. So we actually made some out of brass first before moving to magnesium bronze. So we only made a handful, and I think it was Arnold Palmer who tried it, and there's a little ding that he put in the putter and said, this is a little soft. You might want to try something a little bit harder. And there it was, just kind of, out there sort of on display at the USGA. It was pretty cool.
One thing I want to ask you, because at your level, you I am sure experience this quite a bit. And as you look at the golf industry, with so much of science becoming involved, especially as some people relate it to when the government cut back at NASA, and a lot of people in that industry segued into the golf industry, and it just blew up from there. Whether that's true or not, I don't know. But the science, and as you alluded to earlier, the ability nowadays to measure things that they didn't have many years ago is second to none. And now the application of that science seems to be things that industry is drifting towards. And kind of where I'm going with that is, and Dr. Scott Lynn and I discussed this, for example, what he studies in the lab from the scientific aspect, and then what some of the coaches that he works with bring to him that they're seeing on the lesson tee. So the real world, and then what the lab says. And the one that I'd like to use as an example with you, as far as the club design and functionality aspect, is I had always read and learned that if you wanted to change the center of gravity of, let's say, a driver, that you would have to take a driver of equal, the identical thing, like its twin, and put it, let's say, up on the toe. So the heel, the backside of the heel almost of the second driver would be on the toe of the first driver sitting on the ground in order to move the center of gravity. But then you look at, you could put a piece of lead tape or weight somewhere on the head, and then you're moving that club at 100 miles an hour plus, and now it doesn't necessarily take an entire head mass and weight and everything to move the center of gravity. Can you maybe clarify that or speak to that a little bit on the difference between the science and the applied science? Because you obviously are one who deals in that every single day.
Yeah, it's a good question. So, I mean, and the quick scientific answer is you take any mass and move it, you've moved the center of mass of the club, right? You take 1 gram. The real question is, have you moved it enough to make a difference?
Mm-hmm.
Right? Have you moved it enough to notice? And that's the question we try to answer every day with whatever it is, because, so say I had, a feature that would improve aerodynamics of the golf club. Okay, great. I can tell you definitively improves aerodynamics. Well, then the key question is how much? Because if it increases your swing speed by 0.01 miles an hour, great. Who cares? You're not going to notice it. But if I can do it by 10 miles an hour, it's going to get deemed non-conforming pretty fast. But and then somewhere in between would be where's noticeable enough that it's worth our while developing it, that it's worth our while adding that feature on. It might add some cost, it might give a trade-off somewhere else. So the center of mass thing's the same. So every single gram that I move is going to move the center of mass, and it's actually not complicated science to work out how much, right? Because the center of mass of a golf club is just, you break it down into little 1 gram chunks, and then you work out where that average of those 1 gram chunks is. That's your center of mass.
Because it changes when you shaft it, then, doesn't it? But based off of just a
it does,
head, and then you put the shaft in.
That gets a little complicated, because, and that now we get into some slightly deeper engineering. But yeah, I mean, technically, right, if the whole thing was a rigid system, the whole club's center of mass is actually like off the face, right? It's 6 or 8 inches above the head. And once you factor in the shaft and the grip, and then once you start holding onto it, well, where does the club stop and the player start?
Mm-hmm.
The reality is, you can do some of the maths of this, and trust me, you don't want to get into it, but some people have done this math, and it, because impact is so short, and because there's some flex in the shaft, as a rule of thumb, kind of the bottom quarter of the shaft could be treated as being part of the head. The rest you can pretty much ignore. So having a really heavy or a light grip during impact doesn't make any difference.
Mm-hmm.
It doesn't. Now, it might make a huge difference in how you swing the club, right? Because you can tell when you pick up a club if it's got a super heavy grip or a super light grip. But during impact, it's not making any difference. So you kind of split things into, does it make a difference during the swing? And then does it make a difference during the impact? As it turns out, you don't have to move the center of mass of the head very far at all to make a noticeable difference during the swing. So you can move that center of mass by, a tenth of an inch, which doesn't sound like much at all, right? Is about 10 yards of ball flight difference.
Wow.
But if I move the center of mass a tenth of an inch out to the toe of the club, you can expect that ball to go 10 yards further right.
Mm-hmm.
More fade, less draw, whatever. And part of it is that during the impact itself, there's a slight difference. But probably a bigger part of it is actually just when you swing it, it's a little harder to square up. So as I move the mass further away from your hands, basically, as I move the mass out to the toe, it's just a little bit harder to square up. So you deliver the club face just a tiny bit more open. And so that's where, even though it seems like it's a negligible change in center of mass, getting a little piece of lead tape and putting it on the heel or putting it on the toe can make a difference because it just alters how you square the club up slightly.
Does that have to do with the one term? It's not even a term, but I was always taught and discussed as far as when I was doing some fitting was, and I didn't get into design. I let the other guys who were much more advanced in that take care of that. But one thing that they showed me one time was the arc centerline weighted distribution. So according to the arc, so every club head, let's take an iron in this instance, is designed to function a certain way based off the heel to toe length, the sole to top line, the hosel length, the hosel depth, the weight distribution amongst the shaft, center of gravity, as you alluded to. And then you have parameters that you can work within as far as lie angle, and then how much you can de-loft it or add loft to it. And then within that, you have the weight distribution that the golfer's feeling throughout their swing that can enhance or can affect their swing. And I bring that up because one thing you mentioned was the further that you get the toe away from the head, meaning if you get heads that are bigger, which nowadays seems to be, well, it was the norm. They seem to be shrinking a little bit, that it becomes harder to square up a driver, for instance, that has too big a head. And some people I talked to said there is still some disagreement among guys like not you in particular, but guys like you, as far as, well, should a head be 430? Should it be 330 because you have more mass compacted in a certain area and energy transfer is better and it's easier to square, or is it easier for the forgiveness? And a whole bunch of, I guess I got way too many questions in there and got off on too big a tangent, but I guess the simple question is, at what point, let's refer to the weight away from, we'll call it the center of the axis of the shaft. Is there a breaking point where people find it harder to square up? And then even if you're moving that center of mass or gravity in the head, that it's just not going to function on a consistent basis that you do as the engineer or the player does as someone who's looking to enhance their game?
Yeah. Okay. So there's a few questions in there, but
sorry to get it so convoluted.
It kind of comes back to what we talked about earlier. Just there's a bunch of trade-offs, right? And and I like to start from the experimental side of, like, let's just flat out, what happens if we make this shift? What happens? And then try to, because you can make a lot of things sound plausible, but some really good plausible scientific things don't actually work in practice.
Right.
So we try to start with, okay, what does the data say? And then let's kind of work backwards to, okay, I think this is the explanation that best fits it. But we just see in the data, all things being equal, if you move the mass further away from the axis of the shaft, basically, that's, as you're swinging, you're doing work in a whole number of axes, but one of them is actually just rotation around, with your hands, you have to square the club up, right? You have to turn the head around the shaft axis.
Right.
or at least I guess you don't have to, but players, that's how you swing a golf club, is you open the face on the backswing and then you close it on the downswing. You could conceive of making a robot that didn't do that, but there's probably a good reason why we don't do that. So it just happens that, you actually have to put, if you move the mass further away from the axe of the shaft, you, the player, have to do a little more work to open and close the face, which doesn't necessarily a good or a bad thing, but just in practice, what it means is when you're swinging a driver, or it actually works there for everything from driver down to putter, you end up delivering the face a little bit more open. Now you practice a little bit, get used to the club, you can kind of neutralize that, right?
Right.
A player can just determine that they want to try to turn it over more, but just if in a test, if we test two clubs where one, the center of mass is a little further away and the other's not, that's what you get. There are other things we can do to make a club easier or harder to square up, though. So that's just not the one way of doing it. You make a club just heavier or lighter, like just a heavier club with the center of mass in the same spot is a little harder to square up too. So you can also play with just overall weight. You can play with the depth of the center of mass of the club, so offset, center of gravity depth. So there's other things we can do. It's not just that one thing. And that comes back to, like, in the club design of deciding which combination of factors, often actually having a bigger head and spreading the mass out more is much better for forgiveness, right? It's much easier to make a forgiving head if you've got more space to work with. So like on an iron, for example, a G iron that's a bigger iron is much easier to make that much more forgiving. So now when you miss hit a little out to the toe and heel, you get a more predictable response because the moment of inertia is higher. That's much easier to do on a club like that than on one of our tiny blades, like a blueprint.
Right.
But it's actually easier to make small changes to the face angle with a blueprint, with a smaller club. So you sort of got this trade-off, and that was one of the things I dived into a couple of years ago, was really understanding why do better players hit smaller blades better when even the best players in the world slightly miss hit it, and they're going to get slightly better performance on their miss hits from a G iron. So why doesn't Dustin Johnson play a big cavity back G iron? And it comes down to the trade-offs of, well, the miss isn't just slightly missing out to the heel or toe, it's delivering the face a little open or closed, or it's not going through the turf quite perfectly. So for the better player, more of them get a better result by combining our design trade-offs in a way with a smaller iron. Even though you're giving up something in terms of forgiveness on offset hits, you're gaining in the areas that actually make more impact on performance to that player. Whereas for someone like my dad, typical 70-year-old, 18 handicap golfer, his design trade-offs work much better for like a G iron than they do for a blueprint.
Because that's the level of his game. What he needs assistance
the combination
it benefits
the
him
combination
more.
of misses, exactly. The combination of which where he's missing on the face of the iron, the speed, how he's delivering the iron, face control, that kind of stuff. Like, so for me, for example, my miss is more face angle miss. Like, my disastrous misses are more I've left the face open than I hit it way out to the toe.
Mm-hmm.
And so each golfer is somewhat unique in their signature of where their misses are, and that changes over time. I know you kind of mentioned we'd potentially talk about fitting a little bit, but that's where fitting becomes super important, because you might categorize me as 42-year-old male, 9 handicap golfer who hits his 7 iron about 165. You should play this iron. But until you actually see me take a few swings, you can make a reasonable guess, but that doesn't tell the whole story.
Right. You got to hit them, right?
How am I losing my strokes? And then which iron is actually going to help me do that? So that's part of the fun of fitting, and that's why a good fitting where you really try out a couple of different options is invaluable, because we can put all the science to it we want, but a certain element of trial and error of actually seeing, for me, for all my messy human faults, I'm not a swing robot, right? For all the psychology and the different ways I miss and all this stuff, which one actually works better for me in practice?
That's why there's so many different clubs to pick from.
Yeah,
Well, there's
I
something
mean,
for
if
everybody.
we were designing for robots, it'd be easy. We just have one line of clubs, right? Because the robot does what we tell them every
Hmm.
time. So, in fact, our clubs would look very different if we were designing for robots because they find the middle of the face whenever we tell them, and they deliver the face perfectly square every time. So, a lot of our big design features wouldn't even matter particularly on like a center shot on a robot.
When it comes to innovation, do you tend to look at what you have and then modify it based off of your instincts or experience, or do you look for inspiration outside of the industry, maybe a hobby you have, or let's say it comes to you while you're doing something else, washing your car or cleaning the house? What is there
I'd
one
like
that
to
you
say
tend to gravitate towards?
I'd like to say it's a bit of everything. I think a really rich place for seeing innovations or getting inspiration are kind of what we'd call maybe adjacent areas. Like other sports is really interesting. Things that you see in another sport, particularly motor racing or cycling or other sports that kind of employ technology to try to be the fastest or
Mm-hmm.
best or whatever. Or other industries, automotive, and things like that, cycling. Those are kind of rich areas. I think obviously it sounds a bit corny, but nature certainly is one of kind of seeing some of the intricacies of how things work in nature. And it's not necessarily that ends up directly applying to a club, but just that idea of, okay. I mean, an obvious one for that would be our Dragonfly technology. This was our super thin sections on the crown of the club that kind of allowed us to make a really thin crown section of the driver but maintain structural integrity. Was inspired by looking at Dragonfly wings. That's why it was called Dragonfly Technology. And it was John Solheim's idea. He came back from I think it was a vacation with this amazing picture of a Dragonfly wing and kind of put that picture on our desk and said, do you think we could do that on a driver? And we all kind of looked at him and went, I have no idea, but we'll give it a go and see what happens. And then there's 3 years of trying stuff and failing and breaking things and perspiration and learning, and then eventually it gets onto a golf club. So, innovation isn't all about the inspiration, but it's a cool example of that genuinely did come from seeing something in nature. But I mean, I remember another one of ours was one of our aerodynamics guys was looking at on trucks on the freeway, they have those kind of flaps on the back of the truck that
Right.
they call them like vortex shedders or whatever. They
Uh-huh.
basically they improve the weight behind the truck and increase the miles per gallon by some small amount, but enough to save the company some money. Well, that inspired our Vortec, which was a technology we put on the back of the driver that did exactly the same thing. It enabled us to just reduce the weight at the back of the driver and make a incremental improvement to aerodynamics. It wasn't like 10 yards more distance, but that might have been 1 yard that made up part of the technology for the G driver that it came out on.
When John comes to you guys, and if he doesn't have the idea, like he had the uh, image that he took, and says, okay, in the next 2 years, we want to come up with the next innovative thing, or in 3 years, fill in the blank on the years. Where would you start to look for things to do that? Would it be nature? Would it be automotive or cycling era? Or how would you even start that? Like
Yeah,
you leave that meeting, and it's like, oh, okay, so he wants me
it's
to come up with the newest thing in the entire industry, and you're starting from here, and we have no map on how to get to where we want to go.
I mean, that's the really fun bit of innovation is genuinely sitting down and brainstorming or like, hey, everyone, let's go away and come back in a week and swap notes on what we thought about. And that is, I mean, I think there's a reason why that's kind of people's view of what innovation's like, because it is the cool bit. It's the fun bit of having that eureka moment of like, and it's easy in hindsight, right? When you've done the 3 years of work to get it to market, then you can kind of point back to, oh, I had that moment where it all just clicked. But the reality is you had 9 other moments of ideas that you thought were better, but never panned out. But
How,
it is fun. I mean, and that's, it's a creative part. Like that's not, there has been some scientific tools developed to try to help that along, scientific kind of ways to, or systematic ways to brainstorm and things. But it is it's a more artsy, creative side of it, of having the inspiration, and then the science is then actually trying to prove it out.
how deflating is it when you think you've got it, and then you go in and you run all the tests to make sure, and then it falls short. It's got to be like when you think you have your golf swing, and then the next round you play, you shoot double what your average is.
Yeah,
So
no, that's probably a good
frustrating,
analogy of
right?
you think you've got it all figured out, and then you have your worst round of the year.
Right.
It's really annoying, and the more work you put into it, the more sure you are it's going to work, and then suddenly it kind of starts going the wrong way. Like, hey, we did this test, we got great results, but we tried to repeat it and we couldn't, and it's so frustrating. And it's like, well, clearly there's something we didn't understand. That we thought we understood it, but we must be missing something because we thought we could recreate it and we can't. But it makes it that much better when you do finally get one that, okay, we backed this one up. We were able to repeat it. We're able to. I mean, you can make one of something, but can we make 100 of them, and then can we make 1,000 of them?
Mm-hmm.
It makes it that much better when one does make it through because of all the ones that don't. And some of our best ideas never made it to market. It's really annoying.
Do you still get to use them?
No, I mean, because genuinely, it didn't get to market because it didn't work, and it's just really annoying. It's
Okay.
I mean, part of it's just the deflating thing of like I thought I'd invented the bread slicing machine, and it turns out I didn't. But and part of it's just that kind of like, well, I thought I understood it as well, and clearly I didn't. It's just maybe it's a hit to the ego as much as anything else, but that's part of it. Innovation is difficult. There's no real roadmap for like guaranteeing innovation. You can give yourself much better chances, and there's definitely ways to do it wrong, but it's very hard to guarantee it. And it's very hard to schedule it.
Yeah, it's not a very easy thing that you guys are doing in as many years as the company's been in business. I mean, you're obviously at the forefront and pioneering it, and at the forefront and continue to do it over decades. It's fascinating to me, and I think a lot of people the same. As far as the designs that you've done, and we're talking about the designer clubs right now, to some extent, is there one that you're most proud of that you did an innovative project and it came out, let's say, better than you even had hoped for?
Yeah. So in the interest of clarity, I'm not, and at this point never will be, a club designer myself. So I've not been responsible for like, hey, this was my club.
Mm-hmm.
I was always on the innovation side of things. So trying to tee up technologies. I think the one that stands out is just being kind of ticking all the boxes and being a really fun project, something that led to real performance gains and something that actually got embraced. And we had to go through some blood, sweat, and tears to get there. Was Turbulators. And it started off life as, and Turbulators, if people don't know, those are the little ridges on the top of our crown of every driver we've had since G30. And they're an aerodynamic feature. The Turbulators, because they actually create a turbulent layer of airflow around the club, and they basically reduce the wake. They keep the airflow attached to the club for longer, and you get a smaller wake, and therefore less drag, so you can swing it faster and hit it further. That's the full chain of science to how does it help you score better.
Mm-hmm.
But it came from starting off, does aerodynamics even really matter on a driver? Carsten used to do rough and ready aerodynamic studies and I'm not joking, going out onto a highway sort of out somewhere outside the city, driving 100 miles an hour and sticking the club out of the side of the car, which actually is a brilliant way of doing it. You're creating 100-mile-an-hour steady airflow, and I mean, it sounds hilarious, but actually was probably a pretty effective way of doing it. But we decided we would kind of start to utilize some of these newer computational fluid dynamics tools that were just about getting to the point where they were good enough to model a driver,
Mm-hmm.
which is a surprisingly difficult problem to solve. It's actually easier modeling airflow over a fighter plane than it is over a golf driver. For
Well, is that because the face
reason
is basically flat, leading?
it's it's particularly, yeah, partly it's the shape of the club, it being a kind of blunt body, but particularly the speeds it's going are right on that regime of going from laminar flow to turbulent flow, and that's why turbulators work actually. That if you're going at 1,000 miles an hour, then it's a whole different ball game, and if you're going at 5 miles an hour, it's a whole different ball game.
Mm-hmm.
But we're right in that region where it could be laminar flow or it could be turbulent flow, so it's notoriously difficult to model, which is probably just poured the pants of everyone listening. But it meant that it was a really fun project to start from a point of view of going, okay, does it even matter if we took a really badly shaped driver for aerodynamics and a really good one? Are we talking 100th of a mile an hour or 5 miles an hour? And we did that research. We decided, yeah, it actually does make it. You can change someone's swing speed by a few miles an hour going from a really poorly designed to a well designed club. And then having this idea, which kind of came from other sports, from some winter sports actually, where they used turbulators on helmets for the skeleton. The skeleton is the one where you throw yourself down the mountain head first, like the luge but backwards, right?
Right.
And it looks amazing. But they had these features on their helmet, and it was enough to make a small difference there. And that is, well, we had that spark of inspiration to try them on a golf club. And then when you actually put that club in the wind tunnel and saw that it made a difference, and then we built a driver for players to hit and saw we could measure a difference. And then to get from there to actually incorporating it on the G30 driver and it becoming kind of a marquee technology and people actually reacting pretty well to it. I mean, I remember when we first launched the G30 driver and people were kind of like, well, that looks a bit funky. I'm not sure if I like it or not. But then they got some good results and got used to it. And, it's been on our clubs ever since and has helped because it does help the physics, but it also, was a feature we could talk about and tell the story of. And so that was probably my most fun project.
Well, when you do something like that, do you have to be, do you reach out to the company who maybe you find out developed that or is producing it and say, either pick their brain or ask to look at what they've done and then how you can utilize that in a golf club? Or do you, as an engineer, are your guys' team obviously is exceptionally smart. Do you look at it and say, okay, we can do that on a golf club and we're going to do it ourselves?
Yeah, it's a great question. We actually work with a professor at a university in the UK who had done some consultancy on a couple of other fields in aerodynamics, and we picked his brains. And he's someone who knows more about the fundamentals of aerodynamics than I do or anyone on my team, although we've got pretty good at that in the last 10 years. And, but we know more about golf than he does. So we used him and we used his team to really jumpstart the learning, to kind of bounce ideas off, and then got to a point where we could kind of take it and develop it in-house. But I mean, maybe it partly is because I came from academia myself, and we've got a few guys on my team who are in the same boat that, went through PhDs and so have links into academia. And that's where universities can be great, is, they have this wealth of knowledge. They're not in charge of, of developing products. That's what we do, and that's what we do very well. But so leveraging partnerships with real experts where we can is something I really enjoy and I'm passionate about. And I think we gain some knowledge and then we take it and we know how to develop product.
Yeah, that's got to be that's got to be very cool experience for you to, as a scientist yourself, and then you're in a particular field, but then you go into a field who somebody is studying a very specialized aspect and collaborate with them on how to blend those two things together to the benefit of the people you're looking to help.
Yeah, it is. It is very cool, and we're in the process right now, and later this summer we'll be setting it up. But we're setting up a small research base in the UK to be closer to some of the big sports engineering universities that we work very closely with, and we just see that the deeper we get into the science of anything we can to make golf clubs better, the more we need to leverage those university partnerships. Because every time we make, I mean, it's not just us, every time everybody makes leaps forward in golf equipment technology and the science of it, it just makes it that bit harder next time to find something else that's going to improve performance. So we're getting pretty deep into a lot of things now. We're doing a lot with kind of the human equipment interaction side. We're doing a lot more with like big data than we used to.
Mm-hmm.
You know, our partnership with Arcos and understanding where do people actually find themselves on golf courses, because how you swing on the range is not quite the same as how you swing on the course. And
No.
some people it's more different than others. So that whole area is like still pretty new, and I think there's a lot we can do there. So we employ a lot more mathematicians and data scientists than we used to.
Very cool. Let's talk about something that you, I think, done quite a bit of, and I spent a fair amount of time in club fitting, and but it's not 100% yet, because there was an article I read that you wrote that I found very interesting, and that was on the feels, testing feel in particular on cast versus forged heads, and some of the things you did with that. Can you just touch on that a little bit? Because I think most people out there still have the idea that, well, a forged blade, if you hit it in the center, is going to give you the best feel, period, and a cast club will never even come close. But I think you proved that
Yeah, and it's one of
not true.
those. No, that's exactly the article I wrote was on cast versus forged and the difference in feel and sound. And it's one of those things that like it's just not true anymore. It used to be true though, so you can totally understand why it's a myth that kind of persists and sticks around, because it was the case that 40 years ago, if you were making a club and you were forging it, it had to be made of a pretty plain blade shape, and it
Mm-hmm.
had to be made of a soft steel because you couldn't forge a harder steel and you couldn't forge undercuts and cavities. So forged clubs were muscle back blades. And then what casting was great for, and obviously casting pioneered it, and now everyone uses it. But what casting was great for was making more complex shapes and you could make harder materials that we could go thinner in the face and get more ball speed. You can cast big cavities and create cavity back irons. And so when people are thinking of the difference in feel between cast and forged, what they're really thinking of is the difference in feel between a muscle back blade and a big cavity iron. And usually irons, the muscle back blade is made of a soft steel, and the big cavity is made of a hard steel as well. And so it's understandable that people have this view that forged feels soft, cast feels hard. And my article kind of articulated the fact that it's not really the forged and the cast that makes that. It's the geometry, which is the number one driver. You just get different fundamental vibrational, response from a solid piece of metal than you do from a very thin-faced piece of metal where most of the mass is around the outside. And you think of anyone's played any musical instruments, you know that, you start changing the shape of the musical instrument, you're going to change the note it plays.
Mm-hmm.
And it's nothing to do with whether it was cast or forged, or even particularly the material. That makes a small difference, but it's not as big as the geometry. And so geometry is the biggest determining factor, particularly with irons. If you're within steels, it's very different now if you start adding in new materials, right? Titanium has a whole different sound signature to any steel out there. Carbon fiber obviously adds in a whole new thing. And with irons these days, it's pretty rare to just get a one-piece steel iron. There's a badge. Our badges use aluminium and polymers, and so it's more complicated than it used to be. But just flat out, the conclusion was it's not the case that forge feels soft and cast feels hard. And then I looked at the comments at the end of that article,
Mm-hmm.
and there's a whole bunch of people that said, "Okay, great, that was a nice article. I don't care what you said. Forge feels soft." I was, okay, you know what? You do you. It's all good. I'm trying to help.
Well, aren't a lot of so-called blades today form forged and not pure 100% forgings, or am I way off on that?
Yeah, I think you're right. I mean, I don't know. It's hard for me to speak to what other companies do. I mean, we now have a couple of forged offerings, and that's been a fun project for us because we really didn't do a lot of forging, right? We forged some irons back in the 60s, and then we really didn't touch it again until a few years ago. So it's been kind of fun for my team gaining those skills and optimizing. But some of the stuff you can do now with forgings is, like I said, it's you can use a lot of the same materials as we use in castings. You can forge shapes that there was no way you were forging 10, 15 years ago. There's a lot more design freedom with forging now than there used to be.
Mm-hmm. On the fitting side, and when I was doing a fair amount of it, but this was, God, this is going back to 2006 ish when I got done playing, um, and I saw it change right around then. So probably around the time that you got the ping. But when people would come in, usually with ping clubs, is they would be more upright and stiffer than normal. Normal being a very loose word, or what we thought that the flex should be, and of course then the club would have to be upright to offset the leaving the ball out to the right because the face would never square up. But I've noticed a change in that over the years. Again, roughly since the time you've been there. What do you find with when you fit, let's say for length or lie, and then as you mentioned on, and if you could touch on a little bit as well on the type of club head that person should have based off of their game and what they're looking to improve and enhance, and you're looking to enhance for them.
Yeah, I remember when I started the thing, there was a bit of a philosophical debate, particularly about shaft fitting, and it still goes on to this day. I think is how much do you fit someone to what they're doing right now today versus maybe where they want to be, especially if they're like trying to improve, trying to get better.
Mm-hmm.
Um, and how much do you fit someone for feel versus flat out numbers? And some of these things that are, you think of fitting as being, let's just find you the best combination, but like, what is the best combination is a little bit in the eye of the beholder. And because we're humans, and for some players, it is a bit more important to get the sound and feel to match their expectations,
Right.
even if that means maybe not having what you would recommend if this person in front of you is a robot. um, and so I know when I started, there was a little bit of a tendency to err on the side of fitting people in something stiffer. And I think, I've seen some of the videos from the 70s of Carsten talking about kind of the benefits of his view was fit someone into the sort of the stiffest shaft they can handle. Whereas I've heard other very, very good fitters talk about it doing the other way, of fit someone into the weakest shaft that you can make work for them. So my tendency has been, particularly with shafts, there's so many unknowns in it, and it's so hard to truly understand enough to match your swing to a particular shaft. I mean, that's the end goal, but is to really hit enough shots to get a good understanding of, the pattern, not just the one best one, but which shaft is genuinely helping you find the middle of the face more often. And that's a pretty good indication that shaft is working for you, for your little inconsistencies in your swing. There's things that magnify inconsistencies in your swing, right? And there's things that will sort of minimize inconsistencies. And that's, in the simplest possible way, that's the job of a shaft that works for you, is one that, with your inconsistencies in your swing, they don't get magnified by that shaft. And we've seen it with tour players who are very, very consistent, but everyone has a certain amount of inconsistency that some shafts, they might feel good, they might seem like, stiffness wise, they should be about right. And yet, for whatever reason, that player doesn't find the middle of the face as well with shaft A, but with shaft B, they find the middle of the face much easier. It's just the way that shaft is loading and unloading during that player's swing kind of minimizes the inconsistencies.
Mm-hmm. Yeah, I was talking to a fellow today, a student of mine, long distance, and we were talking very much about the same thing on the different types of shaft uh, and how it relates to a person's swing. And the two extremes that I use because they're the most understandable is if you take let's say that just for the sake of this discussion, that Sergio Garcia and obviously he has a tremendous amount of wrist lag coming into the ball. and Steve Stricker, who has virtually none, were twins. Let's just, like I said, envision that for a minute. And you can make Steve look like Sergio or Sergio look like Steve, whatever somebody wants to do. But even if the flex of the shaft was the same for each, you could never give the other one his twin shaft and play it and have it feel good to that player because the load value is so much different, as you just said. So it's how do you make it when you're working with somebody who they're looking at feel and you're looking at it from a scientific standpoint based off what you know they need off the data that you have and the years you've had doing this. How do you blend those things? And shaft profiles, I think, play a fairly significant role, at least when it comes to matching it to the player's swing type.
Yeah, and the scientist in me says it must be possible to understand why does that shaft feel, why does this player want a shaft to feel a certain way, particularly with players who play a lot, right? With our tour players who come in, they've obviously hit a lot of golf balls in their life. They've tried a lot of shafts. They know what they like and dislike. And I think we can trust that, yeah, when they say they like that feel, it is working for them. Right? They hit enough balls, they do enough trial and error of what works and what doesn't. That if that shaft was really not working, it'd be out of the bag. And if it's really working, it's in the bag. So trying to understand what is it that makes someone like Sergio say, this is the feel I'm looking for in a shaft. And what is it about their swing and that causes them to want that feel? And we've used our motion capture to answer some of those questions. I think we still have a million questions to answer, but we've built some logic to help guide shaft fitting by looking at how players move the club in transition and
Yes.
how aggressively are they bending kind of across the shaft versus along the length of the shaft. And it's helped us explain why some players two players who might have the same swing speed, one is really looking for something body and I want, give me a telegraph pole. I need something that I can't feel move, otherwise it just feels too loose. Versus, no, I want to be able to feel it a bit. I want to actually feel like it's bending a little. And it tends to be those players who load across the shaft that want something that feels stiffer. And then vice versa, the players that load along the shaft are actually looking, because they don't get as much deflection on the shaft in transition. So they could take a stiff flex and just not get as much deflection as someone who pulls across the shaft.
We were Colin Swatton lives in the neighborhood across the street from where I do, and my brother was the club fitter over there for a number of years. And this was when I was doing club fitting, and one of Jason Day, one of his drivers was in the in a hitting area. Or Colin had set it down in my brother's office. I can't remember exactly where. And knowing that Jason at the time, I think he was playing the Project X shafts, and I knew that he, just from watching him swing enough, I knew he had more of a passive release than he did a long, harsh angle into the ball. Again, if I use Sergio as that example on an extreme, and I looked at the shaft and I knew the type, and I told my brother, I said, Jason's going to hate that shaft. He said, how do you know? I said, because it's super stiff in the tiff. It's complete opposite of what he hits most of the time in the field he likes. Well, a couple weeks later, that club was back in there, and I said, what, Jason give up on this club? My brother said, yeah, Colin brought it in and just dropped it off. Said he didn't like it at all. And he said, how the hell did you know that? And I'm not saying I'm smart by any means. I was just, educated by some pretty smart people. But I that for me was a barometer on, is this really true or not? Now that's, you're a scientist, you know that one thing doesn't make a law. But I've utilized that with hundreds of people ever since, and it's come out pretty damn close to true every time.
Yeah, and that's the acid test ultimately. Is does it work? I mean, you can get into some problems with confirmation bias, right? Once you've had an idea, it's easy to see examples where it's working. But ultimately, we can make up all the scientific theories we want. The acid test is, does it work with real golfers?
Right, because they're the ones that got to take it out in the heat of battle, and it's got to perform and feel that the way that they want it to. Otherwise, confidence is such a delicate thing at the highest of levels. I used to tell
Yeah,
right. I used to tell people a lot as we were talking about race cars earlier. I said, playing with your buddies on the weekends is to me the equivalent of driving a car through your neighborhood where you're just idling or going 15 miles an hour. If you hit a 1-inch stick and roll over it, you'll break the stick and no problem. But if you're in a Formula One car going 185 miles an hour and hit the same stick, your chances of you living are probably pretty slim. And meaning that the Formula One would be like a tour level player, right? So any little thing that interrupts their game at that level can have a drastic impact on them.
yeah, you're certainly talking about very fine margins.
Mm-hmm.
Yeah,
That's why I have the utmost respect for people like you, and again, Doc Scott Lynn that was in, and Sasho, and all the coaches that deal with people who play for a living, because just the smallest error at that level that I don't think that maybe some of the average people out there average golfers don't understand. The smallest error at that level can send somebody's career into a tailspin. So the pressure for the people who are doing it every day with them is like yourself is tremendous, and I think you're doing a great job with it. I mean, look at all the guys with Ping who are playing phenomenally. They're not going to do that. I don't like Tony Finau. He's an unbelievable athlete, but you can't give him a broomstick, and he's going to play to the level he does with some of the equipment that you guys have fit him for, right? So it's not always the archer, right? You can't shoot a crooked arrow straight.
they work together hand in hand,
Mm-hmm.
and that's one of the things I'm fascinated by at the moment, and just in terms of understanding it better. It's sort of obvious in a sense, but understanding it's the hard thing. Is the equipment makes you swing differently, and then your swing has different effects on different equipment. So they're a partnership that goes together. And so, like I said, if we're making golf clubs for a robot, it'd be easy. The robot just swings the way it does, and we tweak something on the club and dial it in.
Mm-hmm.
That's not quite how it works with players. It's this feedback loop of, if I give you a different club, your swing is altered just a little bit, enough to notice a difference in something. I mean, not your swing still has a signature of it, but the club changes you, and therefore there's this feedback loop. And when we change things on the clubs, we're also affecting you and the way you play. It's an interesting problem to solve.
Yes, and you're one of the first people that I've heard say that I agree with 100%. In that, if somebody has swung a certain way and achieved a certain level of success, and a club, and that pattern is wired into them, and then you give them a club that's going to alter that pattern, and sometimes you see when these players, I don't care how good they are, but they switch companies. And next thing you know, they're struggling to make a cut, right? And maybe the company that they went to isn't really fitting them or taking all the things into account that you're mentioning. And they're like, well, this one's going to work for you, and we think you should play it. Oh, and by the way, we got that product coming out in 3 months, so we need you to promote it. But again, the proof is in the pudding with what you're doing and the players, the success that they're having. I mean, Bubba's success is no secret. And I don't want to go mention all the names because if I leave one out, I don't need anyone calling me up and say, why didn't you mention me on the podcast? But yeah, very cool stuff. And you do a lot with club fitting, not only with shafts and everything else, but the heads, as you mentioned, and then in particular on wedges, right? And another article I read of yours some time ago, it dealt with the differences of bounce.
Yeah, I think wedges and putters are an area we can probably make a lot of strides in how to do a better job fitting those to the player. And I think part of the challenge is just the variety that we ask of those clubs. Right, so driver in a sense is somewhat easy because you're basically asking the driver to do one thing and do one thing really well.
Mm-hmm.
And it's a pretty measurable one thing too, right? I want to be on the fairway further down. It's a pretty easy objective function. I'm talking engineering talk now, but an objective function to optimize, right? In a fitting, we want to find you the combination of loft and shaft that maximizes your distance and accuracy. Right. Some combination of those in a package that sounds okay and looks good enough, but But when you get into wedges and putters, it's like every shot you hit on the course is a bit different. That that wedge needs to work in dry conditions and wet conditions and fairway and rough and sometimes in the bunker and sometimes out of the trees if you're more my kind of golfer. Um, and everything from 10-yard shots to 100-yard shots or whatever it is. It's a real mixed match, and so what makes for a good comforting then becomes a bit more complex. And so I've been very interested in kind of using a more qualitative approach. It's not, I don't think wedges are all about hit some shots and which one maximizes the spin. That's a part of it. And you want to be able to trust the spin that, if I hit it this way, it's going to come out that way. It's not necessarily that you're always trying to maximize. I want predictability, but I want it to actually go through the turf on fluffy lies well and on tight lies well. And so that's been the challenge, is understanding how bounce plays into that and how to set up a club test. I mean, just in our own world, we kind of call it game-like testing, or game-like fitting, but giving someone one chance at a shot, right? There's the pin, there's the lie. You get one go at this. You don't get to keep hitting it until you pull the shot off. Because to be honest, if you're a half decent golfer, even my level of golfer, you'll figure it out eventually. But it's the wedge that works for you is the one you can do it with first time, not the one you can do third or fourth time, because you don't get 3 or 4 goes on the course.
Right, where someone comes out and hit and drag, and then they hit one that they like to feel, like, oh, this is the club I need. And here you are as a scientist saying, yeah, that's really not how it works.
But it's tricky because on the other side, you like to build confidence, and you build confidence by giving someone a few goes and having them, eventually nail it. And so it's this delicate balance of we're not trying to destroy confidence and make you feel bad about your game, but we need to put you under enough pressure to see if that wedge actually works. And if we just let you stand on the range and hit the shot you're most comfortable with as many times as you like, you're not learning anything about the club.
Mm-hmm.
You're just learning that you can hit the shot you're most comfortable with. And so that's been a fun project, is trying to push people to, doing our own testing, but now start to try to roll that out a little bit in fitting and put people. It's how a lot of the best players do it, by trial and error. They've just found that, yeah, I need to see this. How does it do on that? How does it do on that? How does it do on that? And they effectively put themselves through a little bit of a skills challenge without necessarily realizing they're doing it. I work with Stan Utley, right? Stan's a pin guy and has been for a long time and knows more about wedges than I probably ever will. And I asked him, how do you fit wedges? And he said, I don't know. I've never thought about it. So well, you've got wedges in your bag now, so let's just kind of walk through it. How did we pick them? And so he basically talked me through what he does, and I was like, right, that's what we want to capture. Basically, he just went through something like that. I'm like, well, I need to know how this wedge does on this and that, and he basically described something very similar to what I just did. And I think the same with putting. That we can get you in the lab, we can analyze your stroke, we can understand some of the physics about what putter works for you from the physics side, but then matching your perception with, your perceived expectations of what really happens when you hit putts. You kind of need a variety of scenarios. Just a flat putt in the lab, you can make any putt work if we give you a few goes. You can take a putt that really doesn't match your stroke and still make 3 in a row on a nice flat 10-foot putt. So we did a lot of work with players and identifying, well, yeah, let's set up kind of similar things. Let's set up some different scenarios. I need to see you hit a downhill left or right there where you have to match speed and start line well, otherwise it's not going to work. And that puts you under enough pressure to see, did that putter actually really help, or do you suddenly get tight and something goes, whether it's the speed or the start line.
On the putting side, how do you differentiate between fitting for a putter that will negate the golfer's deficiency, and then trying to get them, because that will at some point max out, right? Because the putter's trying to band-aid something, and then getting them to maybe go a little longer with the learning curve, but in the end, they're going to be a better putter overall, and utilize a putter that way, where they might not see the benefits right away, but in the long term, where maybe you've developed some trust with that fitter or person you're fitting, that they're going to say, okay, Paul, you've helped me with my irons, you helped me with my driver. This doesn't quite feel right, but I've got enough faith in you and trust in you that I'll listen to what you say. How do you make that differentiation?
Yeah, I think the best thing you can do, and what we're trying to do here, and we're still working on that ourselves, but is be as educational as you can to the player, because I think most players haven't really been measured on putts. And, like everyone, if you've bought a driver in the last 5 years, there's a very high likelihood that you've seen your ball speed and launch and spin numbers, because almost everybody fits with a launch monitor now.
Mm-hmm.
They didn't 15 years ago, but with putting, the chances are you've never really seen your numbers. You've got your idea of how you swing the putter, but there aren't too many places that really measure your stroke. And so helping educate, this is what we see, these are the tendencies we see, but your judgment as a player is super important. So we'll make a recommendation for what we think is going to match, but we'll kind of let you guide us on the feel of the missed tendency, and there are certain things that we know if you've got a lot of arc in the stroke and we try to put you in a face balanced putter, the chances are you're not going to see great results on the course. But if the player's going through the fitting and they're like, this just feels amazing, it suits my eye, it's really tough to go, well, no, you can't have that. You're not going to do that. But you're going to say, look, I don't think it really matches your stroke. I think it would be ideal if we could find something that captures the good things about this putter, but with a weight balance that's going to match your stroke, because we've seen from our data. But ultimately, it's the player's decision. I think if you educate the trade-offs and players can make up their own mind, and what we often find is that builds a lot of trust. I'm not trying to sell you on something. I'm explaining what we've seen in our data. I'm explaining, there's no hard and fast rules, but here's what I would like to do is find a putter that matches what we think the physics of your stroke are, but then gives you the feels and the looks that are going to work for you. And that's kind of the holy grail, is to match them up together.
On the ping fitting system, because I'm fairly familiar with it, when you guys came out with the app, I played around a lot with that. And one question I wanted to ask you is, if you have somebody, let's say, has a 7.5 degree arc on the backstroke, and let's say they match it on the through stroke, do you maybe give consideration to giving them more of a face balance to reduce the amount of that arc, so it might not be so highly reliant on, let's say, where the ball position is?
So what we've seen in our data is that if you want to rotate the putter 7.5 degrees, you're going to rotate that putter 7.5 degrees, whether we give you a face balance putter or a really toe down putter. That
mm-hmm.
The forces the putter's exerting on you are a lot smaller than you're able to exert back on the putter. Like, it's pretty easy. It's harder for a player with a driver swinging 100 miles an hour to have full control of what's going on, right? Because the forces add up pretty fast. But with the putter, it's moving slowly. It's you kind of dominate the movement, and we proved that with doing. I know you had Sasha McKenzie on your podcast.
Right.
We did an experiment with him in the lab of actually using motion capture and looking at the motion, the kinematics, what's going on, but then also transferring that to what's actually the forces the golfer's applying. And we showed that we give the same golfer a face balance putter and a toe down putter, and they apply different forces on those two putters to make them move in broadly the same fashion.
That's interesting.
Right? So
that's very interesting.
It's really interesting. So you look at the kinetics, what the golfer's applying as a force, and it looks like almost a different golfer. But you look at the motion of the putters, and there are some differences, but broadly speaking, you'd say, yeah, that's the same player putting. So it's a really interesting Okay, so in answer to your question, we don't really try to make the putter promote a certain style of putt. It's more what we'll say is that a face balance putter is likely to give you more of a left tendency. You're going to deliver it a little more close. So if you're fighting a right miss on the course, that
Hmm.
could be the putter for you. It's probably a bit more of a band-aid type solution, and that at some point you're probably going to find that now you start missing left. But a great example of that would be Louis Oosthuizen. So I remember when we were first developing iPing, we're measuring all of our tour plays. This is when we're just building this. Hey, we've seen in our data that there's this sort of relationship of what we call the fit for stroke. So players that have not much rotation tend to be more consistent with face balance putters, and vice versa. Players that have a lot of rotation tend to be more consistent with toe down putters. And then Louis had just won the Open Championship, uh, putting amazingly at St Andrews with an answer five, a face balanced answer. And of course, he's the one guy we get on our prototype hyping, and he's got tons of rotation. And we're like, oh, well, there goes this dude, right? Like, arguably our best player right now. He's just won a major. But we talked to him about why did you put that putter in the bag? And it was a very clear, I've been fighting a right miss, and I just tried a few different putters, and this one helped me. And And within 6 months, he wasn't playing that putter anymore. And he was actually, for most of his career, he's used the putter with more toe down, like a ZB type putter. And he's kind of bounced around a few different putters, but mostly he's used something that has a bit of hang. The face balance experiment, which worked very well and won him a major, was to address a particular miss and was kind of a short term solution, which doesn't prove anything about our theory, but it made us feel a hell of a lot better about where we were going with I think.
Well, I tell people when I fit them for putters, because I did write a putter fitting program, and they'll ask me, well, what should I get? And we'll go over it, and then I'll say, okay, first of all, go get a backup that's almost either identical, or maybe it's a different brand and just has different coloring, or maybe slightly different shape or lines, or maybe instead of a dot on top, it has a line. I said, and then go get one that's completely opposite of these two. Because at some point, for whatever reason that I don't know anybody that can determine it that I've talked to, there's something in your stroke that your favorite is not going to work. So you bring out the completely different one, as you alluded to Louis doing, and it might work. And then once the novelty wears off, usually in like a week or two, you'll probably go back to your favorite. There's something about that week or two that your favorite spends in the closet in the dark, and it starts to work again. But your explanation and what Louis did speaks to, hey, you can, if you're having a little trouble, you can utilize a club for a period of time to negate that issue,
Yeah,
and
and there's
then
something.
you get your normal stroke. It just ebbs and flows of the game.
John Solheim told me a story about, and I'm not 100% sure which player it was. It might have been George Archer, but I'm not. Don't quote me on that. There's a good player from a while back who was a very good putter, and said to John that every now and again he just needed to look at something different.
Mm-hmm.
And just so he wanted to make a change, not because he was putting, not because anything was wrong with his current putter, but he's like, I've got too comfortable with it, and I need to look at something different for a while, and kind of, I don't know, force myself to concentrate, whatever it is. But subconsciously, it was a feeling that, yeah, I need to just make a change, and then I'll probably go back to my favorite putter, but just for a while, just like what you said then, just needing to look at something different.
When you get into wedge work, do you pay much attention to heel drag at all, either on the design or on the fitting?
Yeah, yeah, we do. I'm not, I'm not the super expert on the design side, but I obviously talk to the wedge design team a lot about some of the stuff, and yeah, they do. They pay a lot of attention to. It's tricky because you're trying to take into account a lot of different ways to deliver the club, and then a lot of different turf conditions, even grass types. But yeah, they do pay attention to that a lot, particularly with the better players.
Mm-hmm. Yeah, because
You know,
they're the ones opening it up and playing. Usually, the better players are playing in firmer conditions, at least around the green. And that's when I was introduced to that back in '05. Not that it was a new concept then, but somebody I can't remember who it was. It had given me a sand wedge, a 56 degree with what was it, 14 degrees of bounce. And I'm a very shallow swinger. I said, "You crazy when we had 14 degrees of bounce?" And they said, "Look at the heel." So, and for those of you that don't know what heel drag is, and Paul, you jump in and stop me if I'm getting offline. It's one the back side of the club that they eliminate a fair amount of the mass on there, so that the heel is not as thick, and which would result in dragging through the turf. Is that a fair
Yeah, so
explanation?
you can have more bounce sort of under the middle of the sole, if that makes sense. But then you can have less bounce down near the heel side.
Yeah, it's cleaner on the heel, and it allows players to open up the face on tight lies, and on thick lies you still have the thick bounce in the middle, as you alluded to. And I hit a couple at that, and I couldn't believe it. I'm like, this is like cheating, and that was new to me. So I that was one thing I earmarked to ask you, because I found it so it changed my wedge game around, because I had just done whatever I could, whatever someone told me to hit, hey, hit this, and okay, it's good. But when I got to a higher level of playing, and someone said, here, try this one and the heel drag was gone, I'm like, wow, this is, where was this 10 years ago?
Yeah, and you'll see that a lot in our kind of custom grinds. There's a lot of players who like to open up the club a lot.
Mm-hmm.
Will grind that area.
Now, you guys, your 2021 putter line is either just launched or it's about to launch. Uh, is
Yeah,
that
so
right?
they just, it's funny how, especially with the last year and all of our product schedules getting kind of messed up by COVID one way or the other. Yeah, yeah. So they came out, I think, in stores, a couple of weeks ago. And they're just called the 2021 putters.
Anything new, groundbreaking that's going to make everybody want to rush out and grab one that you might be able to give them a sneak peek on?
I mean, I'm hoping everyone runs out to grab it. This is an insert line, and one of the things with putters is you can't make one putter that works for everyone. It's just there's so
Right.
much. There's so much. So our line that we launched kind of partway through last year, the Hepler line, they are our firm face, no insert, firmer sounding, firmer feeling putters. So these 2021 putters kind of go alongside them as the insert line. So kind of more think of them as a replacement to the Sigma 2 putters. So they're deliberately a softer feel. It's part of the job of the insert. The other part is it takes mass out of the middle and allows you to increase the forgiveness of the club. So we've worked very hard on the insert, getting that balance of feeling soft but not dead, not too soft. But we added tungsten to all the blades in the line, so that's kind of exciting in a main line of putters to have. The reason for using tungsten, of course, is super dense, so you can concentrate a lot of mass
Right.
in the areas that give you the best performance. So in a blade where you don't have as much room, adding tungsten in the heel and toe can kind of allow you to maintain a small shape, but then maximize forgiveness. And then with the mallets, you've got more room. You're actually using lighter materials. So we're using aluminium kind of in the middle of the putter, and then using steel around the perimeter to maximize forgiveness on those. So each putter has multiple materials. The blades have tungsten with steel. Most of the mallets have steel and aluminium, and then actually our big mallet, the Harwood, is all machined aluminium and tungsten. So it's kind of the maximum super light aluminium, super heavy tungsten. So you're really taking the mass and putting it as far to the perimeters as possible. So I'm excited about that one. That's as stable a putter as we've ever made, I think. Short of something like the Dock that was that huge, the huge putter. It's a fun line. There's a mixture of blades and mallets like we always have. There's some good new models that were inspired by work with some of our tour players. So we're really trying to start with working with some of the tour players. We have our chief putter engineer, Tony Serrano, who's out there on tour, working with the players, making sure we deliver something that suits their eye, but then they can trust that he's got 30 years of designing putters at Ping and work with Carsten and works very well with John to make sure that everything we do has the engineering behind it. But so that's kind of fun that some of those models, the DS72 was a putter we made with Victor Hovland, so he kind of effectively helped us. I mean, I wouldn't say helped us design it. Tony designed it, but designed it working with Victor and using his feedback. And the CA70 putter was a similar project, working with a couple of different tour players on optimizing that mid mallet. Our prime time putter we worked quite a lot with Cameron Champ on that one. So it's fun to see those projects where the tour players have been able to really provide their feedback on what works and what doesn't. And then we've road tested them with some of the best players in the world. And now they're in the main line. So that's exciting.
Yeah, you had mentioned those fellas. I had mentioned Bubba earlier, Tony earlier. It's got to be fun when these guys and the ladies you have, and I'm not as familiar with the ladies tour. Someone out there in today's world who wants to tear this apart, give me some slack. I just don't follow the ladies tour as much as I do the men's, because I have more friends on the men's tour. It's got to be fun when these world class players come in and you get their feedback on something that you're working on in a design or that's going to make the product that much better. And you got some of the longest hitters in the game between Bubba and Cameron and Tony, and you got up and comers like Victor. That's got to be a blast when they come to town.
Yeah, it's great. And you're talking about our tour players and our elite amateur players are the people who use the clubs more than anyone else, right? Tour players hit more balls than almost anyone else.
Mm-hmm.
And so they understand their games. They understand exactly what they're looking for from the club, and usually can articulate that. If you can ask the questions in the right way, you can articulate that in a really good way. This time last year, actually, we were when nobody was leaving the house, we were able to do a bunch of Zoom calls with a bunch of our players to just talk equipment, and it was great to just have a captive audience for an hour. And I gathered 5 or 6 of my team and said, right, let's pepper them with questions about their equipment. What do you want this to do? If you could wave a magic wand, what would you like to make? Three woods and wedges are kind of interesting ones to chat with the players about, because they ask a lot of those clubs. Most of the time, driver's easy. Just get me one that goes longer and straighter. Easy to say, at least. Whereas 3-woods, everyone's a little bit different in what they want out of the 3-wood. What's the miss that they're most scared of with the 3-wood? Are they looking to hit that kind of high bomb? Are they looking to kind of hit to a number? Yeah, and the same with wedges, just the variety of what players want. So really understanding what are you trying to do, and then let's figure out how we can go away and develop the science to deliver it better for you.
I could see that in 3-woods in particular, because some players are looking for more or less of a backup driver for those dogleg holes that they either can't cut the corner with the driver, and they either want to hit it around a little bit around workability around the corner or hit it to the corner. But that always doesn't serve the same purpose as somebody who wants to take their 3-wood into a par 5 and have enough height on it to be able to somewhat hold the green from 270 yards away. So I can see 3-woods having a wide variety, as you said, right? Because it has to serve so many purposes.
I think it was during all these gear calls I think it was Stuart Sink who kind of articulated that very well. He just, as he thought about it, said, I think we ask more of our 3-wood than we do any other club in the bag, and maybe that's why when you fall in love with the 3-wood, it's very hard to change it.
Mm-hmm.
So it was a fun, succinct way to put it.
Yeah, he had a hell of a week last week, didn't he?
He did. That's cool. It makes me think I haven't hit my peak yet. I like that.
One thing I got to ask you, the putter room, that every player that plays a ping putter, if they win, they get you guys have a gold-headed one, platinum, is it gold-plated, and they get a gold-plated?
Yeah, we make 2. So if you win a professional, I don't know exactly which tours qualify which time, but if you win on a major professional tour with a ping putter, we make 2 gold-plated copies of that putter, so the exact model, and then we'll inscribe, the name, the tournament, and the year, and we'll keep one in the vault and then give one to the player, and then for majors it's solid gold.
Wow.
So it's really cool. And I don't know exactly when it started, but we've sort of gone back and filled in the gaps to, everyone back to the very first professional win with a ping putter. And it's something like 3,000 putters in the vault. It's a cool piece of history and also a very bling room. But to go through, and I think the fact that it's, each putter is a replica of that player's putter, so you see the variety. You can go and look at Seve's 42 putters in there, and Lee
Wow,
Westwood's got
that's awesome.
50 in there, and Tiger's amateur wins, and there's the history in there, all the majors. There's a few non-putters in there to kind of commemorate particular, shots. I know there's Bubba's wedge from that
The
famous
10th hole
shot.
at Augusta, yeah.
Yeah, and there's one of Cal Cavecchia's 5-iron from the Open Championship in the 80s. It's a cool thing. I think the players like it, and certainly I'd like it if I was a player. And it's a really cool way to capture the history.
What do you do when you start running out of space?
We move the room. I've seen us move the room to a bigger spot. We're actually somewhat running out of space again.
That's a good problem to have.
That is a good problem. I don't want to tell people to stop winning. It's really cool. I think I haven't met someone who doesn't like to go and see to go and see that room. It's really cool.
Mm-hmm. From an engineering standpoint and somebody who works with clubs and designing and all the things that you do, what is your take on some of the independent testing sites? Like the major golf publications each year come out with the hot club list, and you have other outfits now. Like I think My Golf Spy is probably one of the biggest ones. Do you think they give a fair evaluation of products and equipment in today's world?
That's a tough one. I think they do. I think they do a pretty good job with something that's almost an impossible task.
Mm-hmm.
There's too many golf clubs out there. If you want to test everything, I mean, I've talked to the guys at My Golf Spy, and they've asked for giving them some little tips on how to set up the testing. And usually I start with, well, if I was trying to do a good player test, I wouldn't start with 35 drivers. But that's their reality, right? They want to test everything, and it's an awful lot to ask of people to get good data and whatever. But by and large, I think they do as good a job as they can, and it's got better over the years. I think everyone, at least all the folks that I've seen and talked to, generally it's got better over the years. It's no test you're going to do is going to be super definitive, right? At the end of the day, you're just buying one club out of our offerings, and you can't really go through a full fitting, and then you're comparing it to one club out of someone else's offerings, and so it's going to get biased by does that club happen to be reasonably well suited to the player, and that's fine, right? It is what it is. It's not a definitive, well, therefore this test proves that all pings are better than all TaylorMades or vice versa. I think if you take it for what it is, it's a decent stab at doing a comparative test, and I would caution people against making their entire buying decision based on reading one test,
Right.
But I think they're cool, and it's helpful, and it might point you to, hey, that did better than I thought. Maybe I should go demo that. I mean, I'd always encourage people to go think of the 2 or 3 main choices you have, and at least try those.
Like at a bare minimum, it's bringing more people to go consider other options where they might not consider it before.
Our aim is we just want to be in the mix. When you go for a fitting, we want to be one of the brands you try, and we think it'll perform well enough that a decent number of people will buy it. And it doesn't mean you're going to win every time, but we want to be in that group of, if I'm buying a driver, I at least want to consider paying.
Mm-hmm.
And then you let the demo kind of do its thing.
And then you have the faith that you've done a good job with everything you were responsible for, and you guys are the winner in the end.
Yeah, and ultimately, if you deliver a good product, then the next time that person's going to be more likely to buy from you again because they had a good experience. And, if someone is super satisfied with their 14 pin clubs, and when it comes to buying new clubs, they just go straight to buying 14 more pins. I'm okay with that too.
Right. One thing I want to ask is as we talk about drivers because it's such a big topic right now in the golfing world is we're in the distance era. I think it could be coined or tagged. Your opinion on does there need to be some sort of balance between technology and then making some courses maybe traditional becoming obsolete, and it kind of where if you were the one in charge, how would you go about utilizing each to the benefit of the masses or the whole of people who play?
Yeah, it's such a difficult one. I mean, I think that's partly why the debate rages. And and for historical context, and I'm not the expert, but I've read enough about some of these things. This debate's been going on for at least 100 years and probably more. When the Haskell balls came out, there was people up in arms that classic courses are going to be obsoleted by players. I read Alistair Mackenzie's book from the 30s talking about how courses are going to be overwhelmed by players who can carry it 220 yards. I mean, imagine that. So it's sort of, the debate's probably always going to be there. I think it's a fair debate to have. I mean, I grew up, I played for 7 years in St Andrews, where you don't have a lot of room to move tees back.
Mm-hmm.
But then, is the old course still a good test of golf? I think it is. It's not the same test that it was 50 years ago, but I think it's still a good test. The challenge is just, where do you draw a line? If you kind of, I don't think people want to see. Well, I don't think most people want to see no innovation in equipment and balls. I think there's a sort of excitement about that. I mean, maybe I'm biased working in the equipment manufacturing side of things, but people actually enjoy buying new clubs and balls and discovering new technology that helps them out. And there's talk of, well, what if we had one set of regulations for the pros, the infamous B word,
Right.
Bifurcation level, but whatever that could look like. Other sports manage it just fine, right? It's not, golf isn't the only sport in the world, so you can look at other sports and how they manage it, but it could get complicated. And I think that's the challenge, is could you do it in a way that doesn't confuse people, that you can sort of be a beginner golfer and then graduate up to being a tour player in a somewhat seamless way without this sort of dividing line of, I don't know. I think that's kind of a challenge, but I'm not, we've sort of come out and said we're not opposed to the idea of regulations changing. We're opposed to the idea of it being kind of arbitrary and not in the best interests of, maintaining healthy competition and these kinds of things. It's just, the devil's in the detail of like, what exactly would you do?
Yeah, and I don't remember if it was Andrew Rice when he came on, or I had Tim Morgan, who was the USGA chief agronomist at one time. One of them, I think each one of them said, Tim said, when it was either he and I discussed it or he and somebody else said, I don't want to watch a black and white TV, not when I can watch a 65-inch high def. And I think Andrew told somebody or asked somebody if they got to his lesson by riding a horse or if they drove in a car. Right, and it's pretty obvious which one you want to do, and you can see that side of the argument. But the other side, and I'm playing devil's advocate, of course, is okay. But at what point do you have to say we can go to here, but if we keep going, we don't know what can happen.
Yeah, it's one of the best arguments I read, and it's back to the Alistair Mackenzie book from the 30s. But he was commenting on the distance debate at the time, and he was in favor of regulating distance. And his biggest argument is the most fun in golf is hitting golf shots. I want to do more hitting golf shots and less walking. And I thought about that and was like, actually, that's a pretty good argument. I don't know. I mean, there's, my dad is not hitting the ball too far and in need of his distance being regulated.
Mm-hmm.
Is Bryson in hitting it too far and in need of it? I don't know. I don't mean, there's more of an argument for regulating his driver than there is my dad's. But if we all want to play the same game with the same regulations, that gets tricky. So that's the fundamental issue that golf has to wrestle with, right? Is do you want to take 20 yards of distance off my dad driving? And probably not. So are we okay with some kind of bifurcation or whatever you want to call that condition of competition?
It's
It's
going to
tricky.
be, yeah, it's going to be interesting to see play out on how that happens because no matter which way it goes, you're going to have a lot of argument, I think.
Yeah, well, I'm just, watching another sport I really enjoy, soccer, having big debates about creating a European Super League and all the mess that just caused last week. So, I mean, it's not the only sport having these existential debates.
It's just, I think throughout time, as you alluded to, it's St. Andrews and Dr. McKenzie, and it's always been a topic. It's just maybe not back then. They didn't have social media and all the outlets that you had so many voices chiming in at the same time.
Yeah, there probably is a link between distance and pace of play as well, though. It's probably worth being part of that debate. And
You
I
know,
think it'll be a few years of a lot of debate and a lot of proposals and reasons why it won't work, and who knows.
as we're winding down on time, one thing I wanted to ask you that when I was playing, I didn't get my PGA Tour card, but I played at fairly high level for a while. The public's perception of what a long driver is, not long meaning the length of the club, and what the tour pros actually use. So last I was privy to the info that most of the tour guys were using drivers. Was it 44 and a half to 44 and 3/4 inches, and average Joe's out there trying to get 47 inches because he thinks he's naturally going to get more distance. And I'm like, well, if the best in the world who are looking to optimize distance and direction are using less than 45, why are you swinging 47 when you have a directional issue to begin with? It is. Do you see in all the work that you're doing a benefit for the average Joe out there who's listening, or let's say they're even a 10 handicap and they want to pick up distance to go longer in their driver or their clubs on length?
Yeah, there can be. I think I mean, like you just kind of mentioned, it's not the be all and end all. You're right. At least among our RPGA Tour players, the average driver length is somewhere around 45 or there or thereabouts, just a little below.
Yeah, I think.
Interestingly, our LPGA players, on average, are a bit longer. So although they're, on average, smaller golfers, they're the average driver length on the LPGA Tour is a little longer than it is on the PGA Tour, which and they're golfers who, by and large, are hitting a lot of fairways and would like to squeeze a bit more distance out. Not all of them. That's kind of a generalization. Whereas, like you said, more of the PGA Tour players already have a lot of speed and a lot of distance potential and are looking to find that balance of enough distance with enough fairways. Or at
Yeah,
least
I think Cameron said, did I hear him last week or week before where he said his driver was like 44 and a quarter or something like that. He
yeah,
obviously has plenty of horsepower. He doesn't need the speed. He's looking to keep it in play. But I found that
I think
very
that's
interesting.
what's impressive about a lot of these players is what you see on TV is by no means them swinging flat out. And I know now with social media, some of these players will post some of their flat out swings, and and you see ball speeds over 200. You don't see that on the course because the consequences of a big miss at 200-mile-an-hour ball speed are a lot higher than the consequences of a big miss at 180, say. So
There's a big cost to that
they're
step
doing
and accelerator.
they're doing the math in their head, and you can talk to someone like a Mark Brody or a Scott Fawcett about whether they're doing the math correctly or not, but they're doing the math in their head as to what's the right trade-off for them, for their game, for that course, as to you know how much they want to get after it and how much they want to swing within themselves.
And along those lines, is shafts start to get lighter? In your opinion, at what point does a shaft become too light where it doesn't provide enough resistance, and the golfer, be it a 18 handicap or a world class golfer, starts to lose feel because they're not getting any feedback or limited feedback? You have any thoughts on?
Yeah, the weird thing, if you sort of ask from the flat out physics standpoint, the perfect shaft is zero mass and very stiff. If you were just asking the physicist who's never seen golf before, what would be the best? Because kind of all that mass in the shaft is sort of wasted mass that you have to do work to swing it, but it's not contributing to impact. But like you said, that it's not like a perfect amount of design freedom. Like taking mass out means, you're making compromises on stiffness somewhere. Whether it's like the flexibility of the shaft or the torsional stability of the shaft or whatever. So usually there's a trade-off of going lighter means having some kind of different feel and potentially, fundamental loading and unloading. So where we can, if we can maintain the same feel, taking mass out is a good thing because we can put more mass in the head and you can still swing it just as fast. But we try to kind of push that in incremental changes because trying to make a huge change at once really does affect the feel of the club to the player.
And the weight of a driver head, are you trying to keep it at the 198 mark, or do you go up to 200, or do you ever go plus 200?
We try to get just above 200, and that's with our builds for kind of regular customers. Our stock shaft is counterweighted, meaning we try to have as much of that. It's lightweight, and we try to have as much mass more at the grip end, so that like you can calculate for a shaft like its contribution to the swing weight of the club, right? So a heavy shaft contributes more swing weight. A shaft where all the weight was kind of close to the head would have more swing weight contribution because you got to work harder to swing it. So our stock shafts have a very light swing weight contribution so that we can put more weight in the head, but have the same swing weight. And what that means is, at least in theory, and our data would back this up, you can swing it just as fast, but if there's more weight in the head, you get better energy transfer. So all things being equal, which is a big statement, a 205-gram head, you're going to get a bit more ball speed than a 200-gram head. That extra 5 grams is more energy transfer. But it has to be all things equal. I mean, we could just make the head really heavy. We can make it 300 grams. You just wouldn't be able to swing it very fast. So
especially the bigger the arc that somebody gets, they're having to be able to move that mass on that big arc versus a shorter one. At least I would have to think so.
So it just turns out that for the range of abilities of most golfers, the physics plays out that about 200 grams is the sweet spot. Whereas if you went way lighter, you don't swing it fast enough to make up for the fact that you've lost energy transfer. And if you make it super heavy, you don't get enough energy transfer to make up for the fact that you're swinging way slower. Like the sweet spot tends to be somewhere around 200 grams.
Does there seem to be a sweet spot for shaft weight? Is it 65 to 70, or is it 70 to 75 or 75 80?
I think it's been a kind of slow trend over the years going lighter, and it's partly the materials available. Right, not all carbon fibers are the same. There's different grades and modulus and stiffness and whatever. And if we can use stiffer fibers without more weight, if we can get the same stiffness properties in the shaft with less weight, we will in general. You just have to balance durability. Like the stiffer fibers tend to be more brittle, right? So you don't want to bring in durability concerns and some of that kind of stuff. But it's been a sort of slow trend over the years that we're just inching our way lighter and lighter.
I was really big on filament wound shafts. And the first one I ever had was from Ping and the old ISI head.
Oh wow!
And they were the pulling and the twisting almost like a cotton candy, not a cotton candy, but like a taffy. If you ever seen taffy be made, it's stretched, and as it was pulled, it was twisted, and then I just assumed that however much, if they twisted a certain amount, it would be stiffer, and if they twisted a little less, it'd be. But the play, not the play, the playability factor came out to, if you did it off of cycles, was about 8 cycles less, had the same playability as, let's say, a table rope type graphite shaft. And then, well, this is really dating me, and then the playability factor compared to steel. But the filament wound was much more consistent as far as had less deflection. If you put it on the freak machining and you move it, it didn't oscillate. And I'd always just found them to be more consistent. And then when I did the fitting, that was the same. But I bring that up because the first one I had was from Ping.
Interesting. That one's just a little bit before my time. So
yeah, that was back in 01, 2000, 2001.
I'll have to ask our shaft guys a bit more about it. You probably know our director of shaft development, John Oldenburg, joined us last year. He was at Aldila for a long time, and more recently LA Golf Shafts, and having him in-house and part of the team is great, because he knows so much about developing shafts. So he's got 25 years of designing golf shafts.
Mm-hmm.
So that's been we've always prided ourselves on designing our own shafts and making good stock shafts, but bringing him on board is giving us another leap forward even there.
Whole new level.
So I'll have to ask him his experience with filament wound shafts.
If I still had it, I'd tell you which one it was. I just don't. I have no idea where that driver is now. that was 20 years ago.
Nice.
But the consistency and the playability was second to none. Now maybe it just, this was before I knew hardly anything about club fitting. Maybe that it just matched my swing, and as we talked about, load transition better. But I hit about a 4-yard cut with that thing, and I hit it every single time.
Very cool. Well, I'll have to go and dive into that. On that note, I'm afraid I'm going to have to run. I didn't realize we've been talking for
no problem.
2 hours.
It runs quick. We'll skip the rapid fire. We usually do 9 rapid fire at the end, but if you promise to come back, we can do it again. And I won't take up as much time.
A couple of minutes. I'm just going to have to go in a couple of minutes. If that's right. I just got a call from one of my counterparts across the way.
No problem. All right. So we call it the emergency 9. So if you made the Ryder Cup team, the very first hole, what would be your walk-up song?
Oh, I'll go Proclaimers, 500 Miles. Obviously, I'm representing Europe here.
Yes.
And my 7 years in St. Andrews, it's got to be the Proclaimers.
Okay, cool. Caddyshack, Tin Cup, or Happy Gilmore?
Caddyshack every day of the week.
Best ball striker you ever worked with?
I literally work with Marty Jertson. He's played in 6 or 7 majors, so I'll have to say him.
Okay. And everyone you follow, Jerdy Bird, is that his handle?
Jerdy Bird, yes.
Jerdy Bird, yeah.
Bird.
Follow him. He's got a great...
I literally work with him, and he designed the G30 driver and a bunch of our other stuff. So that's
cool.
Kind of a privilege to work alongside someone who's played in majors.
All right. Putters, mallet or blade for you?
Blade. I just struggle with balance.
Okay. Last book you read?
Golf Has Never Failed Me by Donald Ross, The Lost Manuscripts. I joined a golf book club, and I've been reading some of the old classics.
Very cool. Not surprising that you look to educate yourself in other areas outside of what you're doing. Dream foursome.
Dream foursome. Just selfishly, I would love to play with, with a mixture of English golfers. I'd love to play with Faldo, Lee Westwood, Tyrrell Hatton.
No one can fault you for that. Let's see. A couple more. If you could change one rule in golf, which would it be?
Oh, that's a great question. Selfishly, stroke and distance for out of bounds. I've fallen foul of that so many times.
I think there's a lot of people listening that would agree with you. Let's see.
Help my own game here.
Go-to drink on the golf course.
in the interest of being a good ping company man here, I'll say a Perrier sparkling water.
Okay. And the last one, this one we give to everybody. In your opinion, who's the GOAT in golf?
That's a pet hate of a question. Only as I'm going to give you a super long answer for a quick question. Only as much as it's impossible to define. It's impossible to compare people across eras, and to truly say if you took Tiger and put him in Jack's era, or you took Jack and put him in Tiger's era. So just to be annoying, I'll say Bobby Jones.
Okay, it's
he won all 4 in a year, so the other two didn't do that.
That explanation you gave is a very reasonable one, and it's hard to argue that. All right, I know you need to run. Dr. Paul, thank you. I know everyone's going to enjoy this. I'll have in the summary, as always, all your links to you and Ping's website and your social media handles. So everybody follow Dr. Paul Wood. You will learn a ton. You'll help your game. And Doctor, thank you so much for making the time to come on. I really enjoyed it.
Thank you.
You have a wonderful night.
Cheers.
All right, everybody. Thank you so much for listening to today's show. If you enjoyed it, you can find more information on today's episode and other topics at golf360.blog. There you'll find the show notes and links related to this episode, as well as any other episode that we've done so far to date. If you're interested in improving your game and would like to learn more from yours truly by taking a private lesson, a half-day or multi-day school, club or putter fitting, you can reach me through the blog site or by email, pete@golf360.blog. So some of you may be asking, what is the golf paradigm? All you have to do is click on the homepage while on my blog site to discover how you can start playing better than you ever thought possible. Or you can simply sign up, again, on the blog page for my instructional videos where I give regular tips on all areas of the game to include the swing, club design and fitting, health, fitness and nutrition, the mental aspects, and equally as important, the integration of all those things together. I'm also on social media, and you can find me at The Golf Paradigm. That's PARADIGM. And I'm on Facebook, Instagram, and Twitter. And don't forget to subscribe to my YouTube channel, also under the same name, The Golf Paradigm. Facebook is usually the best way to reach me for questions and or comments, and I look forward to hearing what all of you have to say. This podcast is brought to you in part by Old South Golf Links. A short ride across a bridge from Hilton Head Island is one of the area's finest golf courses and a hidden treasure. Set up on towering pines and ancient oaks with sweeping marsh vistas, truly makes Old South Golf Links a one-of-a-kind golfing experience. The Clyde Johnson design was named one of the top 10 new public courses when it opened, and it also takes full advantage of the natural beauty of the Low Country. Old South is a fun and unique challenge for golfers of every skill level and a favorite of both locals and visitors. Whether it's your first time here or you're a regular, you'll be treated and feel like family. From the bag drop to check-in at the fully stocked pro shop with both men's and women's apparel, to breakfast or lunch before or after your round, the staff is always ready and willing to help. Experience for yourself why Old South is one of the premier golf courses in the Hilton Head area and why it will quickly become a favorite of yours too. Visit them in person or online at www.oldsouthgolf.com, or to make it tee time, simply call the pro shop at 843-785-5353.